they're released from rest when their separation is d. What are the speeds of the spheres when they collide? When they collide, the separation becomes R1 plus R2. So when I say separation between spheres, of course we mean separation between the centers of the spheres. So what are their speeds? When this will be moving with some velocity v1, and this will be moving with some velocity v2. What are v1 and v2? Well, first of all, those speeds, those spheres carrying plus and minus charge, they attract each other. And because they attract each other, that's why they move towards each other. That is, there's a force acting on the sphere on the right, a force to the left, and so it moves to the left with acceleration. And there's a force acting on the left sphere. The force of attraction is to the right. It's attracted by the second sphere. And so it moves to the right with acceleration. So they move with acceleration, and then they collide. So the question is, when they collide, what is the speed? What are the speeds? What is v1 and v2? Again, we have two instances in time. Well, at one instant, the spheres are held fixed at a certain separation. In the other instant, they're moving and they have a new separation. So how do we find v1 and v2? Conservation of energy. Initially, it's kf plus uf. Initially, ki is 0. This is not moving, this is not moving. And then the two spheres are separated by a distance d. So there's electrical, or there's electric potential energy. What is electric potential energy of two spheres separated by a distance d? It's Ke, the constant 1 over 4 pi epsilon 0, times Q1 times Q2 divided by the distance between them, which is d. Distance between the centers. It's just like 2 point charges. If I have 2 point charges, Q1 and Q2, what's the potential energy? K, Q1, Q2 over R. So K, Q1, Q2 over R. R here, of course, is just the distance between the spheres d. This is initial energy. Now, but of course the charge Q2 is negative, so I should put, so this becomes minus here. Or I can just put here minus Q2, whatever you like. It's the first charge times the second charge. The second charge, I'm calling it minus Q2. Now, it's negative. So this is the initial energy. What is the final energy? I have half m1 v1 squared, because now this is moving with v1 squared, plus half m2 v2 squared. And then we have also the electric potential energy, which is plus Ke, again Q1, the first charge, times the second charge, which is minus Q2, divided by the distance. The distance now is R1 plus R2. Now I have, everything is known here except v1 and v2. Those are my unknowns. So I need another equation. And then I can solve for v1 and v2. What is the other equation? Conservation of momentum. Now, true, there is a force on each one of them. But taken together, there are no forces from outside acting. So when I think of the system as consisting of the two spheres, those two spheres, they're only subjected to internal forces. One sphere attracts the first attracts the second, and the second attracts the first by equal and opposite force, by Newton's third law. But there are no forces from outside. Nobody is from outside is pushing this sphere or pushing that sphere. So since there are no external forces, the momentum is conserved. And so the initial momentum is equal to the final momentum. But initial momentum is zero. Because initially they were at rest. The final momentum is m1 v1 plus m2 v2. So this means that v2 is minus m1 over m2 v1. Of course, it's negative because v2 is to the left and v1 is to the right. So if v1 is positive, v2 is negative. So now I can put for v2 this value. So I get something times v1 squared. And here v1 squared, so I take v1 squared as a common factor, and I take this to the other side, and I solve for v1 squared. Very simple. And once I find v1 squared, I find v1, then I find v2. So from here on, the problem is just simple algebra. Everything is known except, as we said, v1 and v2. K, q1, q2, d, r1, r2, everything is known. And v2, now that we know that v2 is minus m1 over m2 v1, the only unknown becomes v1 squared, which we can easily solve